Previously, we looked at uniform discrete distributions where each individual probability was 1 over n, equal to 1 over n. So like rolling a die, each value of the die has a 1 in 6 chance of happening. Well, for a continuous uniform distribution, we have the same thing. We have a fixed value for our probability density. So that's going to be a straight line. And we know that this will be between A and B. Elsewhere it'll be 0. We also know this whole area is 1. So this length is going to be B minus A, which means that this value here must be 1 over B minus A, so that when I integrate, my area will be 1. Well, what this means is that if I think about the cumulative distribution function, then I'm taking the probability that x is less than some value t between here. So I'm going to take, so the probability that x is less than some value x, and I'm looking between a and b. That's going to be my integral between a and x. So now I'm going to use a different variable for my function so that I can integrate. So I know that the value of this function is 1 over b minus a, and I'll integrate with respect to t. So when I integrate, I'm going to get t over b minus a, evaluated from a to x. So that's going to give me x minus a over b minus a. So this is my continuous distribution for my cumulative distribution. Now, if I think about my expected value, so I know that expected value is going to be my integral over the whole domain. So in this case, it's going to be a to b because it's 0 elsewhere. And then I'm going to have x times f of x. So x, my f of x is b minus a dx. All right, so if I integrate this, I'm going to get x squared over 2 b minus a, and I'll evaluate from a to b. So that's going to give me b squared minus a squared over 2 b minus a. Of course, this factors into b plus a, b minus a, so my b minus a's are going to cancel, and I get b plus a over 2. Now if I think about my variance, that's going to be e of x squared minus e of x quantity squared. So e of x squared, that's going to be integral a to b x squared over b minus a dx minus this quantity squared. So integrating, I'm going to get x cubed over 3. So evaluating from a to b, that's going to be b cubed minus a cubed over 3 b minus a minus, this is going to be b squared plus 2ab plus a squared over 4. If you create your common denominator and simplify, you're going to end up with b cubed minus 3ab squared plus 3a squared b minus a cubed, all of that over 12 b minus a. This, of course, becomes b minus a cubed over 12 b minus a, which is, there's an extra b over there, b minus a squared over 12. So these all define a uniform continuous probability distribution, and we denote that as x is a uniform distribution between a and b.